Next theorem, that is a result. If C1 and C2 are the centers of the given circles with the radius R1 and R2 respectively, and one pair of common tangents to the given circles meets the line joining the centers C1 C2 at P, and another pair of common tangents meets at Q, then the point P and Q divides the line C1 C2 in the ratio R1:R2. We'll see the proof. Given two circles with center C1 and C2 and radius R1 and R2, right? So C1, this is the radius R1, and C2 the center, and this is R2, the radius of the second circle. So common tangents, there are two common tangents, right? So P is the point of intersection of the two common tangents, and another two common tangents. So one is direct, other one is transverse, right? So point of intersection is Q, right? So let the first pair of common tangent meets the circle at T1, T2, T3 and T4, right? So first pair, so T1, T2, T3, T4, transverse common tangents meets the circles, both circles, right? That is the first circle with center C1, it meets at T1 and T3, and the second circle with center C2, it meets at T2 and T4. And the second pair of common direct common tangents meets the circles at T5, T6, T7 and T8. So first circle meets T5 and T7, and second circle meets T6 and T8, right? Join C1 and C2, join the centers of the two circles, so you will get a straight line C1 C2, right? Join C1 T7 and C2 T8, right? C1 T7 and C2 T8, right? So we join C1 and C2 and extended that one, it will meet at Q, right? Consider the triangle PC1T3 and triangle PC2T4. In these triangles, angle T3 and T4 are 90 degree, right? Because C2T4 is radial. In the second circle, C2T4 is the radial axis, right? Radial line, and that tangent, that is T4 T3 T4P R, right? It is a tangent. Tangent is always perpendicular to the radius, so that is 90 degree. Similarly, here the T4, similarly the T3 at first circle, right? T3P is a tangent and C1 T3 is a radial line, so that is perpendicular to the tangent, so that is 90 degree. Now angle C1P T3, which is equal to angle C2P T4, right? Here C1P T3 and C2P T4 are opposite angles, both are equal, right? Next, the remaining angle in the triangle PC1 T3 and PC2 T3, right? Both are equal, right? Because the total angle is 180 degree, so sum of these three angles is 180. Therefore angle PC1 T3, which is equal to angle PC2 T4. Therefore the both triangles are similar, right? So using the property of similarity, we will get C1 T3 the side divided by C2 T4, which is equal to C1P divided by C2P. The ratio are equal, right? So this implies C1 T3 is R1, C2 T4 is R2, right? R1 by R2 is equal to C1P by C2P, right? Therefore C1P is to C2P is equal to R1 is to R2. Hence P divides the line C1 C2 in the ratio R1 is to R2. Consider the triangles, triangle QC1 T7 and triangle QC2 T8. So in this triangle, similarly T7 angle T7 and T8 are 90 degree, and C1 angle C1Q T7, which is equal to angle C2Q T8. So the argument is same like the previous, right? Hence the angle QC1 T7 is equal to angle QC2 T8, right? Therefore these two triangles are similar, so using the similarity property, C1 T7 by C2 T8, which is equal to C1Q by C2Q, that is R1 by R2 is equal to C1Q by C2Q. Therefore C1Q is to C2Q is equal to R1 is to R2. Therefore the point Q divides the line C1 C2 in the ratio R1 is to R2. Next we are going to see the definition. Similitude, right? Center of similitude. Consider two circles with center C1 C2 and radius R1 R2 respectively, right? So two circles join C1 and C2, right? The centers. In this case there is a possibility of having two pairs of common tangents. So this one and this one, right? One is direct, other one is transverse. So transverse point of intersection, transverse tangent point of intersection is P, and the direct common tangent point of intersection is Q, right? In this, right, this pair of common tangent intersecting at a point P on the line segment C1 C2 is called transverse pair of common tangent. The pair of common tangent intersecting at the point Q, which is not in the on the line segment C1 C2, it is called direct common tangent, right? The point P and Q are collinear with the centers C1 and C2. The point of intersection of P of the transverse pair of common tangents is called internal center of similitude, right? Suppose the transverse point of intersection, right? Transverse tangent, common tangent point of intersection, that P is called internal center of similitude. Then similarly the other point Q, the point of intersection of the direct common tangent, which is called the external center of similitude, right? Here the point P divides the line segment C1 C2 in the ratio R1 is to R2 internally, but Q divides the same line segment C1 C2 in the ratio R1 is to R2 externally, right? These are all the results. So if the circle is not intersecting each other, C1 C2, the line distance, right, center distance between the center is greater than sum of the radius R1 plus R2. So R1 not equal to R2 means in this case both the internal and external center of similitude are exist. In this case total common tangents are 4. All the 4 common tangents exist and internal and external similitudes are exist, right? Case 2, R1 equal to R2. So this is the case, right? So P is the point of intersection. If suppose R1 equal to R2, then the direct common tangents are parallel, right? And hence the external center of similitudes does not exist because direct common tangent does not intersect, right? They will not intersect anywhere, so you will not get Q. That is why there is no external center of similitude. In this case total common tangents are 4. If the circles are touching each other, C1 C2 is equal to R1 plus R2. So this is like this, C1 C2 is equal to R1 R2. So only one common tangent at P, point of intersection, right? So in this case internal center of similitude is P, is the point of contact of the two circles, right? Clear, right? In this case total common tangents, so that is only one transverse common tangent, right? So 2 the direct common tangent, so total number of common tangents 3. The given circles are intersecting each other, right? So C1 C2, so they are intersecting each other, so direct common tangent exists, so point of intersection is Q. In this case there is no direct common tangent because there is no, right, you cannot draw a transverse common tangent for this case, right? So there is no internal center of similitude, so only external center of similitude exists, so only 2 common tangents exist. The circles are touching each other internally. C1 C2 is equal to R1 minus R2. So like this, right? So here in this case internal center of similitude P does not exist, right? Because you cannot draw transverse tangent, but direct common tangent exists. And the external center of similitude Q is the point of contact of the two given circles. Here only one common tangent exists. If the circles, if one circle is lying completely inside the other without intersecting, C1 C2 is less than modulus R1 minus R2. So in this case, there is no common tangents and no center of similitudes, right? Thanks.